In this video, we're going to look at a special type of right triangle, and this would be a right triangle with angles of 45 degrees, 45 degrees, and 90 degrees. Before we actually start talking about the triangle itself, one thing that we need to do is make sure we know what 45, 45, and 90 are in radian measure. So let's convert those really quick. 45 degrees, remember if we want to convert that to radians, we multiply by pi over 180 degrees. So our degrees are going to cancel, and in our calculator, if we type 45 divided by 180, we get 0.25, which is 1/4. So pi fourths radians is the same as 45 degrees. That's going to be important in some things that we'll be doing in the future. And then we've already talked about how 90 degrees is the same as pi halves radians. So go ahead and try to remember that 45 and pi fourths are the same. So we can write this as a pi fourths, pi halves triangle if we're talking about radians. Okay, so in a 45, 45, 90 triangle, all you need to have labeled is the right angle and one 45-degree angle, because we know in a triangle that all three angles have to add to 180. So if you have these two, you automatically know that this one's 45. So you don't necessarily have to see another 45 written in there. All right, so there are some special rules that we can use to quickly find the missing sides of a 45, 45, 90 triangle. And to do that, let me illustrate a couple things. First of all, if these two angles are 45 degrees, so they're congruent, the sides opposite those angles are also congruent. So this side and this side, which are your two legs, are always going to be congruent in a 45, 45, 90. And then obviously that side is your hypotenuse. Okay, so for simplicity's sake, let's let one of those legs have a length of 1. So if one leg has a length of 1, that means the other leg also has a length of 1. And then if we want to find the hypotenuse, we can do the Pythagorean theorem. We can do 1 squared plus 1 squared equals, I'll just use h for hypotenuse squared. So 1 squared is 1, plus 1 squared is also 1, so that gives us 2. Equals the hypotenuse squared, and then we're going to square root both sides. So our hypotenuse is equivalent to the square root of 2. So this gives us an important rule for our 45, 45, 90. If we want to get from our leg to our hypotenuse, let's say we know the value of our leg and we want to get the value of our hypotenuse, that formula is going to be leg times the square root of 2 equals hypotenuse. And it doesn't matter which leg you're given, you can multiply by the square root 2 and you'll get what your hypotenuse is. So you need to memorize this formula for your 45, 45, 90 triangles. And then also remember that your leg is going to equal your other leg. So there's another important one. Okay, this gives us some more important information as far as it deals with right triangle trig. We've talked about our 6 trig ratios. We have the sine of theta, and we're going to let our theta be 45. Cosine and tangent. Let's go ahead and talk about what the sine, cosine, and tangent of 45 degrees is always going to be, since we know that this ratio of our hypotenuse and our leg. Remember, sine is opposite over hypotenuse, so compared to our 45-degree angle, no matter which one you look at, your opposite side is 1, your hypotenuse is square root 2. So the sine of 45 degrees is always going to be 1 over square root 2, no matter how big or small the triangle is. What we need to do is rationalize that, though, because we can't have the square root 2 in the denominator. So that gives us a value of square root 2 over 2. We need to go ahead and start to memorize that the sine of 45 degrees or the sine of pi fourths is always going to be the square root 2 over 2. Same thing with cosine. Cosine is adjacent over hypotenuse. The adjacent side in a 45, 45, 90 is always going to be 1, hypotenuse square root 2. Same thing, rationalize So I'm going to get square root 2 over 2. So the cosine of 45 degrees, no matter how big or small the triangle is always going to reduce to square root 2 over 2. And then tangent, remember, is opposite over adjacent. So if we look at our 45-degree angle, our opposite side is 1, our adjacent side is 1. So 1 over 1 is 1. So the tangent of 45 degrees, or the tangent of pi force radians, is always going to be 1. So these trig ratios and these special right triangle rules need to be memorized. Go ahead and start working on that. Okay, so now using these special right triangle rules, I've drawn a 45, 45, 90 triangle here, and I've given you some different sides, and I'm just going to let the legs be A and B and the hypotenuse be C for now, so that we don't have to keep drawing more triangles. And we're just going to find the two sides that are missing. Remember, if you're given a leg already, you automatically know what the other leg is because they're congruent. So really, it's just a matter of finding the hypotenuse. Okay, so if we look at number 1, we're given that A is 5. Well, if A is 5, B is also 5. Okay, to get C, C is our hypotenuse. Remember our formula, the hypotenuse is always the leg times the square root of 2. So our C value is our leg, which is 5, times the square root of 2. So it's just going to be 5 square root 2. Now for the assignments you do for me, I would like your answers left in simplest radical form. So your answer for that would be 5 square root 2. My open math does allow you to put some decimals in there. So as a decimal, 5 square root 2 is 7.07, or approximately 7.1. But again, for what I'm going to have you do, practice leaving them in simplest radical form. So those would be your answers. Okay, for number 2, we're given A is 2 square root 6, so that automatically tells us that B is 2 square root 6. Okay, to get C, we're going to take that leg and we're going to multiply by the square root of 2. So we have 2 square root 6 times square root 2. Well, when you multiply two radicals together, you multiply what's inside. So the square root 6 times the square root 2 is going to be the square root of 12. So we have 2 square root 12 as our C value. Now, that is not considered simplest radical form because that 12 can be broken down into its prime numbers. So if we branch 12 out, we can get 4 and 3, or 2 and 6, depending on how you want to branch it. And then for 4, we get 2 and 2. So I have a pair of 2's that I'm going to pull out front. When I pull a 2 out front with a 2 that's already there, I multiply those numbers. So I'm really going to have a 4 out front. And then I have this 3 left over that didn't get a radical. So my C value is actually 4 square root 3. And then my B value is 2 square root 6. So again, whenever you pull a number to the front of your radical, if there's already a number there, those numbers get multiplied. Okay, for number 3, we're given B. B is square root 3. That's a leg, so that tells us A is also square root 3. All right, to get our C value, we're going to take that leg and we're going to multiply by square root 2. So our leg is square root 3 times square root 2, which is square root 6. Now, in this case, 6 does branch out into 2 and 3, but it doesn't branch far enough for me to get a pair of numbers like I did in the previous one. So I'm just going to leave this one square root 6. C is square root 6. So these first 3 examples, you were given a leg and you had to find the hypotenuse. Now, in these last few examples, we're given the hypotenuse and we need to find the legs. So think about what we'd have to do differently. Whenever we wanted the hypotenuse, we had to take the leg and multiply by square root 2. Now we're going backwards. We already have the hypotenuse and we want to get back to the leg. So think about that formula. If we want the leg, we would have to divide that square root 2 to the other side of the problem. So now we're going to kind of use this formula. When we want the leg, we want to divide by the square root 2 instead. Okay, so look at number 4. Our hypotenuse is 7 square root 2. So to get my leg, and it doesn't matter whether it's A or B, in fact, I'm going to write it like this, A and B. We know they're going to be the same. So A and B, I'm going to take my hypotenuse and I'm going to divide by square root 2. And this one works out nice because those square root 2's are going to cancel. And my answer is 7. So for this problem, A and B are 7 units. All right, number 5. My hypotenuse is the square root of 10. So to get A and B, I'm going to take the square root of 10 and I'm going to divide by the square root of 2. Now, because these numbers can be reduced and they're both in square roots, I can reduce them like they are. We know that 10 divided by 2 is really 5. So I can write this as just the square root of 5. Now, if those numbers didn't reduce, then I would have to rationalize this problem and get rid of that square root 2 in the bottom. But since they do reduce, I don't have to do that. So A and B are the square root of 5. And remember, you can only reduce numbers that are both in a radical or both out of a radical. You can't ever reduce a number that's in a radical with a number that's not. All right, number 6, C is 3 square root 5. Okay, so to get A and B, I'm going to do 3 square root 5 divided by square root 2. Now this is an example of a problem we'll have to rationalize. 5 and 2 do not reduce. So I'm going to have to multiply top and bottom by square root 2. So on the top I get 3 square root 10, because 5 times 2 is 10, over square root 2 times square root 2 is just 2. Then one thing you always want to check on problems like this, since this number is not in a radical, see if it'll reduce with that number out there. In this case it doesn't, so that's our answer. So that is our A and B value, 3 square root 10 over 2. And number 7, C is just 8. Okay, so if we want to get A and B, we want to get our legs, we're going to take 8 and we're going to divide by the square root of 2. Now I cannot reduce this 8 and 2 because 8 does not have a square root and 2 does. So I am going to have to rationalize top and bottom times square root 2. So the top gives me 8 square root 2. The bottom just gives me 2. Now this I can reduce. 8 divided by 2 is just 4. So my answer comes out to be 4 square root 2 for my A and B value.